It's really a great pleasure to be here. When Vicente invited me, it was very easy to say yes for two reasons. One of my favourite academic visits I've ever gotten to make, actually, as an economist, was coming over to SEMFI and meeting the crew there. And it also turns out today's my birthday. So the invitation was... So the invitation was to come over and meet many of the economists I've enjoyed reading over many years and renew acquaintances with old friends in a wonderful city on my birthday. So that seems pretty irresistible. I want to talk today about some work with David Rothschild. David was one of my graduate students, and David's now at Microsoft Research. And as I understand it, very timely given developments in Spain. If you want to forecast elections, how best to forecast elections. And so the task we set ourselves in this paper is really pretty simple. You know how standard public opinion polling works. Whenever we talk about who we think is going to win, we usually refer to public opinion polls. Those public opinion polls ask people who they intend to vote for. So it'll be some version of who do you think you will vote for in the election for president? And this is as true in Spain as it is in the US. What very few people know, or very few in the forecasting business have appreciated, is actually for many, many years, many public opinion polls ask the second question. And I'm going to call it the voter expectations question, saying, regardless of who you plan to vote for, who do you think will win? And so the task that we set ourselves in this paper is actually a very, very simple task, which is saying there are two competing technologies for predicting election outcomes. And the question is, which technology is better? The fact that I think it's worth spending an hour talking about this question comes from the fact that I end up with an answer that is maybe not the one that you would expect. So if you look at the way public opinion polling works, at the moment, pollsters and the news media put 100% of their weight on polls of voter intentions, and they barely ever bother reporting what it is that voters expect. Instead, I'm going to make the argument that asking voters who they expect will win yields far better forecasts. So the motivating idea here, I think, is pretty simple, which is if I ask you about next week's election here in Spain, there's a lot of things you know about the election. For sure, you know about who you're going to vote for. You probably know who your better half is going to vote for. If you've been to the water cooler at work lately, you may have also heard about how some of your friends and colleagues are thinking. You may have seen how many people have bumper stickers on their cars or yard signs out the front. You know whether a representative of the local party came and knocked on your front door. So there's a large amount of stuff you know about the next election. When we ask you who you plan to vote for, we're only asking for a small part of your information set. When I ask you instead, who do you think will win, effectively I'm asking you, what does your whole information set tell you? And so then the implication, this is, it's very standard economics, more information is better. So therefore, if I ask a question that extracts more information, it's probably not surprising that we're going to get a more accurate forecast. So that's the underlying idea. But the paper really proceeds in two halves. The first is pure black box, simply to say, here is one technology for forecasting elections, asking people who they're going to vote for. Here's another technology, asking them who they think will win. Which technology does better, right? I don't need to ask why. All I need to do is figure out how these do and see which one is closest. And then the second half of the talk, I'll come back to the more social scientifically interesting thing, which is then to ask why and try and give you some sense of what I think is going on. So let me put this in a broader context. One of the things I've done work on in the past is prediction markets. A prediction market, if you don't know, is a market where you can buy a stock that's worth $1, say, if the Democrats win the next election in the United States. Right now, that stock is selling for about 58 cents. So I think we can infer from that, taking a market price as a risk-neutral probability, the market believes that the Democrats are around a 58% chance to win the next election. And much of the work we've done on prediction markets has been about showing that these market-based forecasts yield more accurate predictions than things like public opinion polls. So then the question is why? So one reason is just when I force people to put their money where their mouth is. When you bet in a prediction market, you're more likely to tell the truth. And so if you turn on American cable news any night of the week, you can see people, talking heads, pontificating about who's going to win the election. And it turns out the guy from the Democratic Party always thinks the Democrats are going to win, the guy from the Republican Party always thinks the Republicans are going to win, and what you've got is just a whole lot of hot air. But if we force those people to bet instead, maybe we'd get truthful revelation. Maybe that's part of it. Another possibility is that it's about weighting, right? So the problem with public opinion polls is when you ask 1,000 people, you then usually give roughly equal weight to each of the 1,000 people. But we don't all have equal information sets, right? And the thing about a betting market is if you really believe something because you have really good inside information, you'll bet more money. Whereas if you're not sure, you won't bet anything. And so one of the things that markets do is markets give different weight to different people's opinions. And so maybe the reason that markets do a good job at predicting election outcomes is just they give more weight to more informed people. Maybe. But this paper comes at it from this third possibility, which is maybe it's just about asking the right question. So what do prediction markets do? You bet on who you think is going to win the election. Effectively, we're saying, who do you think will win? Public opinion polls instead say, who do you intend to vote for? And so if it is this third idea, that all we've got to do is ask the right question, then we don't need all the machinery of markets. All we need to get efficient information aggregation is to go out and ask people who they think will win rather than who they intend to vote for. And that's useful because trying to implement prediction markets can actually be very difficult. In the US, there's a lot of anti-gambling laws, and as a result, it can be illegal to set up prediction markets where you may want to. And it can also be difficult. But if we can get much of the same oomph, the same useful forecasting ability from just asking people the right question, it would save us a lot of time. And so then that's what sort of got me motivated in this question. Is it just about asking people the right question, who do you think is going to win, rather than who you intend to vote for? And then there's this broader question as to, if that's the case, what are the broader lessons from this? And this is actually why I'm really excited about this work. I think predicting elections is moderately interesting, but I think this idea that you can do a better job at forecasting stuff by asking people what they think will happen has far greater applicability. I'm going to give you two examples, but let me also add, I'm still very much in the market for looking for what the next big application of this idea is. And so if this talk triggers any ideas, I really would love to hear from you about it. But let me give you two specific contexts. So the first is in macro. So in macro, one of the things we often track when we're trying to figure out what's going on with the economy is consumer confidence. One of the ways in which we measure consumer confidence is we ask people what they intend to do. So for instance, in the Michigan Survey of Consumer Confidence, we ask people, do you intend to buy a refrigerator or other large appliance in the next 6 months? So this is a lot like, who do you intend to vote for? What if instead we ask people, do you think people like you are going to buy a lot of refrigerators in the next 6 months? It's a more useful question because the first question, do you intend to buy a refrigerator in the next 6 months, is shaped, the answer for me is no, but it's got nothing to do with the business cycle. It's because my refrigerator works. And so there's a whole lot of people who are asking the survey and eliciting no useful information. But if instead I ask, do you think friends and family or do you think people like you are going to buy a refrigerator in the next 6 months, maybe I'm going to learn something more general about how do you perceive economic conditions more generally. So maybe there's an application to macro and better ways of measuring consumer or business confidence. Let me also give you what I think is the broader implication of this, which is maybe in market research. So I spent many years of my career working in business schools, and business schools have these departments called marketing departments. And I know all about them because they're the folks who get paid more than economists. And the more I got to know what they did, the more that horrified me. So marketers will do these things called focus groups, which to an economist makes no sense. We're going to get 12 people in a room, and we're going to say to them, next year, should the Gap make, blue jeans or red jeans? And if everyone says, oh, I think, you say to these 12 people, what looks better, red jeans or blue jeans? If they all say red jeans, then the Gap will go out and make red jeans next year. They'll invest millions of dollars making red jeans. And if the 12 people say blue jeans, then they'll spend millions of dollars making blue jeans. Now, you can see the obvious problem with this. When you ask 12 people, nothing's statistically significant, right? I would not invest millions of dollars in the opinions of 12 people. But what if instead we asked each of those 12 people, do you think your friends are more likely to buy red jeans or blue jeans? What if each of those 20 people has 20 friends? Well, then each of those 12 people is bringing the information from 20 other friends. The 12 people around the room in the focus group now represents 240 people. It's not quite a huge sample, but the central limits theorem starts to apply. But more to the point, 240 responses that represent the preferences of 240 people may be enough to actually provide useful information. So maybe there's a way in doing this that we can do a better job at market research through things like focus groups. If we ask people, are we going to sell more red jeans or blue jeans, instead of asking, do you like red jeans or blue jeans? That's the idea. So let me take a step back. What I've just done is basically revealed the fact I got my PhD at Harvard, which is I've completely oversold you on a whole bunch of promises that have nothing to do with what my paper's actually about. So I'm not going to talk about red jeans and blue jeans, and I'm not going to talk about consumer confidence any further. These are sort of like the reasons I'm excited about this idea. But instead what I'm going to do is I'm going to use predicting elections as my laboratory for trying to test these ideas. And so the idea is, can we do a better job by asking people what they think will happen rather than what they intend to do? So let me move on to using using that laboratory to see what we can learn. So here's my data. What I'm interested in doing, and apologies for being US-centric about this, is I'm interested in trying to predict the outcome of elections. So here's all US elections from 1952 through to 2008. And what I'm going to do is I'm going to treat all US elections as if they're a two-party race, which is basically true. But anytime someone votes for a third party, I'm just going to throw it out because it doesn't matter. And that is, the reason I'm going to do that is because it doesn't matter. I'm going to code each election as having been won by the person who became president, which in 2000 was actually kind of controversial, right? So I'm going to say that Bush, in fact, beat Gore because that's what the Supreme Court said. It doesn't matter for what I'm going to do. So these are the results. How might I forecast these results? One thing I could do is take a public opinion poll. So the data I'm going to use in my study come from what's called the National Election Studies, which is a very standard US political science data set. Typically about a month before each election, they survey 1,500 Americans. And they ask them a whole bunch of questions, including who do you intend to vote for? And you can see that these surveys, typically taken a month in advance, usually predict the winner. But they don't always, right? So in fact, a month before the 1960 election, 55% of people said that they intended to vote for Nixon. 45 said they intended to vote for Kennedy. Kennedy ended up winning that election by 0.1%. We see that there are 4 cases, in fact, that I've highlighted in yellow, where the poll predicted the wrong person, the person who didn't ultimately become president. A different technology for trying to predict these outcomes is to ask people who they expect will win. And so now I'm reporting the proportion of people who expected, for instance, Eisenhower to beat Stevenson, or who expected Obama to beat McCain. The first thing I should say is, this is obviously a very... And so, actually, let me go back a step. If anyone says that they expected a third-party candidate to win, then I'm going to throw them out of my sample because that's crazy. And if anyone answers one of these questions, the expectations question, but not the intentions question, or they answer the intentions question and not the expectations question, I'm going to throw them out of my sample because what I want to do is I want to make sure that it's an exactly fair fight. I have exactly the same people in my sample both ways. And the only difference is which question I'm focusing on. When we're looking at this number, though, we should realize it's a very different number. So when 65.7% say that they expected Obama to beat McCain, this is not a statement that they expected Obama to win 65.7% of the votes, obviously. It's simply that most people understood that Obama was going to beat McCain by whatever margin it turns out. And so you see that, this technology predicted Obama would beat McCain. A majority predicted Obama would beat McCain. It predicted a majority predicted that Bush would beat Kerry. But actually a minority predicted Bush would beat Gore. Okay, so you can see actually there are 3 cases where this technology got the wrong answer, and it got it right in every other case. So how do I compare these two? Well, here we have 4 cases. If you ask people who they intend to vote for, we got 4 elections wrong. If you ask people who they expect will win, you've got 3 elections wrong. 3 is fewer mistakes than 4, so therefore my technology is better, right? This is, of course, the problem of politics, which is, for all the talk of big data, politics is the ultimate small data problem, which is we only get an election every few years, and there's nothing we can do about that. So rather than declaring victory, what I'm going to do is it turns out that I can go to the state level. So the same survey doesn't just ask who you intend to vote for and who you think will win, but it also says, what about here in Michigan? That's the state I currently live in. You can hear my strong Michigan accent, in fact. Which candidate for president do you think will carry Michigan? Okay? And they ask this in every state. So now I'm moving from having a dozen elections to having many states in a dozen elections. And so now I'm going to move to having a total of 345 state-by-year electoral college races. They're obviously not completely independent, so I can take account of the interdependence when I estimate my standard errors. So I have this survey from 52 to 2008. The funny thing is, this question that I'm interested in, who do you think will win, is one that political scientists think so little of that every time they threaten the budget of this survey, they cut my favorite question. And so this question was not asked between 56 and 68. And in fact, it wasn't asked in 2000, which is one of the most interesting elections of our lifetimes. So in the end, though, now I have 345 state year electoral college races. Let me tell you that I'm using these data because they're convenient, not because they're great. And it's not that there's any more convenient data, right? You got to go to war with the data you have, not the data you want. And these are the data I have. So, for instance, this survey doesn't go into every state every year. Usually they figure, we surveyed some people in North Dakota. There's no reason to ask people what's going on in South Dakota. They're all the same. So they're not in every state. The other thing is, this is a national survey that has 1,500 people. But when I go down to the state level, all of a sudden my sample sizes get very small, right? So my sample size in some cases is typically about 30, 40, 50 people. In some cases, for instance, in North Dakota, it's literally one person. They call one person in North Dakota and they're like, that's enough. And then, they might go to California and call 246 people. So this is not exactly what a standard poll looks like, but it's the best that I have for testing my hypothesis. So this now is my data. So now I have 345 races. That's enough. We can do some analysis. So what I do is for each race, I simply say to a majority of which candidate did a majority of people in this state expect would win that state, right? And then which candidate did a majority of people in that state say they would vote for? When I focus on voter intentions of my 345 races, the standard polling question gets the answer right in 239 of them. So the standard polling question got the answer right in 69% of all cases. Instead, if I ask people who they expect will win, I move from getting 239 races right to getting 279 races right. So now I get 81% of all races correct. So that difference is clearly statistically significant. It is, to my eye, large. You move from getting 31% of all races wrong to 19%. And more importantly, it comes for free. All I had to do was analyze data that already existed and was already on the shelf. Just ask the right question, you get a big increase. Let me say, I think, if anything, this understates the improvement that we get here. And the reason I say that is in most cases, who do you think will win points in the same direction as who do you intend to vote for. And so in those cases, they're not really a good trial for my test, right? Because they're both pointing the same way. So all the oomph comes from those few cases where they point in different directions. So it turns out that of my 345 races, they both point in the same direction and are both right 217 times. And they both point in the same direction and they're both wrong 45 times. So in fact, there are only 83 occasions where these two measures point in different directions. So what we really care about is in those 83 cases where different questions lead you to different predictions, how well did each of them do? So let's zoom in on those 83 races. And we find that in those 83 races, when they point in different directions, the expectations method, asking people who they think will win, predicted the winner 76% of the time, whereas the intentions method was correct only 24% of the time. So that's the sense in which now I start to feel really confident that my measure is doing a better job, right? And this is also the point at which I apologize for showing pie charts. I spent far too much of my career in business schools, and that's what you do when you're teaching a business school. Let me say, stop here. I just want to underline this result because I'm going to do what all economists do, which is I'm going to keep blah, blah, blahing for the rest of the hour. But this is actually the main result. And everything else that I'm going to show you is just going to dot the I's and cross the T's. But the main result is just change the question. If they point in different directions, I get it right 3/4 of the time. And this is a better method for forecasting outcomes. And the rest of this, I'm going to go back and show you that this is robust. It may be even truer than I'm stating so far, but this is sort of the main result. Okay. So this is also a result that's not just a result of any one election. So I've got 14 election cycles in my data. And in fact, the green bar is how many did you get right using the expectations question, how many states, and the blue bar is how many states did you get right using the voter intentions question. And you can see that the green bar is higher than the blue bar. That is to say, you would have done better using my question than the alternative in every single election cycle with 1.5 exceptions. The 1.5 exceptions are there was one cycle where they disagreed about Minnesota, and Minnesota doesn't matter. They disagreed about Minnesota, and Minnesota went the wrong way for my measure. So that's the one election cycle I didn't get it right. And actually in 2008, they both pointed in the same direction on every single race. And so there was just no distance between them. But apart from that, the green bar, so this is not a new feature of the data, and it's not an old feature of the data. It's a relentless and ongoing feature of the data that green bars are bigger than blue bars. So here's another way of trying to figure out, of comparing the ability of, the forecasting ability of my measure with a different measure. And I don't know if this is a good or a bad way of, I can never figure out whether this is a useful straw man or a useful alternative. So recall what I was doing in my last comparisons was comparing what would happen if you predicted who would win using who do you expect to win versus asking people who they intended to vote for. Here's another possibility. Imagine a public opinion pollster who could travel through time. And so that person would go and ask people in a month's time who they actually voted for, and then they'd travel back and they'd say, here's my prediction. And so it turns out in the data set I'm using, they actually do that, which is a month before the election, they ask people who they intend to vote for and who they expect will win. And then a week after the election, they ask people who they actually voted for. And so I'm saying, would you have done a better job predicting the election outcome, asking people who they expected to vote would win a month before the election, or who they actually voted for a week after? And now, who they actually voted for is not going to be perfect because, again, we're taking samples, and all samples have sampling error, right? And so it turns out that a majority of people said that they voted for the winner 71% of the time, whereas the majority of people expected the winner to win 81% of the time. So another way of saying this is, my measure, asking people a month before the election who they expected would win, still does a better job when I compare it to asking people after the election who they intended to vote for. So this method actually does better than a pollster who could travel through time. That's obviously a little glib, but I just thought it was an interesting comparison. Okay. So here's where I want to go. As I said, the rest I think of as being largely dotting I's, crossing T's, and maybe trying to draw out some of the broader implications. So what we've done so far is I've just treated this measure as a binary indicator, which is to say, what's my prediction? Will a Democrat win or will the Republican win? Now, one of the things that's doing is it's throwing away a lot of variation, right? Because if the Democrat wins by a lot, did my measure say it was likely the Democrat would win by a lot or by a little? And also what it's doing, remember, is it's throwing away all those elections where both measures pointed in the same direction. So what I'm going to move to instead is trying to predict not who's going to win the election, but predict the actual two-party vote shares of each party. I'm going to do that in a very simple way. I'm then going to do it in a complicated way. And then you'll see the same results both ways. And then I'll talk about some archival data. And as I said, the second half of the talk is when I'm going to come back and ask the question why. And I'll write down a very simple model to do that. So here's the data on voter expectations. And I'm going to show you a lot of graphs that look like this. So each observation is one of my state-by-year cells. The horizontal axis shows you the proportion of the two-party vote share that intended to vote for the Democrat. So you can think about that's the standard polling result, right? What proportion say they intend to vote Democratic? And the vertical axis shows you the actual Democratic vote share. So the good news for pollsters is that these data sort of point in a northeasterly direction, which is to say when more people say they're going to vote for a Democrat, more people actually end up voting for a Democrat. So that's sort of the good news. So that's going to be one of my comparisons. How well do we do? And then the dashed line here shows you the 45-degree line, which is to say it shows you what a perfect prediction would look like. So these circles, which are the size of these circles is proportional to how many people are in my surveys, they're not right on the 45-degree line. So it says that standard public opinion polls still make a lot of mistakes. So it's easy to think about how well I judge a standard polling question for how close it got to the answer. What's harder is my expectations measure. How do I convert my expectations measure into a prediction of a two-party polling, of a two-party vote share? Here's what I mean. In 2008, 56.6% of people said they intended to vote for Obama. 65.7% said that they expected Obama to win. He won 53.7% of the vote. Which of these two measures was closest? Which was least wrong? And the problem is that the 65.7%, the proportion who said that they expected Obama to win, can't be directly compared to the actual vote shares, right? Because it's not this many people saying who they expect to, that this is how they expect to vote. So what I'm going to need to do is find a way of converting the 65.7% who say they expect Obama to win into a useful prediction of Obama's actual vote share, right? So I need to do one more step. And then after that, once I've done that, then I can say which one was closer, what had the smallest mean absolute error, what had the smallest root mean squared error, what had the highest correlation, all the standard forecast evaluation things that we do. So my next job is to turn this 65.7% number into a number that could be usefully compared to the 53.7 that Obama actually won. How am I going to do that? I'm going to write down the smallest, simplest, dumbest model that I can. And the reason I'm writing down a small, simple model, there's more complicated things you could do, is I want to tie one hand behind my back. I don't want to be fixing things to help my measure too much. So here's my simple model. Each voter has an expectation about the final vote share. So expectation is going to be X's, and the actual vote share is going to be a V. So each of us sees some noisy signal about the true vote share. The true vote share is V sub R, and we see it with noise, epsilon, right? So for instance, you have some signal that says, according to your view, Obama's going to win 53.5% of the votes. In my data, I don't ask you how much do you think Obama is going to win? I simply ask you, who do you think is going to win in your state? So this is going to be you're going to say, well, I think it's going to be Obama if my signal says that Obama is going to win more than 50% of the votes, right? Otherwise, I'm going to say I think it's going to be McCain. So this then tells us that the probability that you think the Democrat will win is just, and here I'm going to now add my one extra assumption, which is I'm just going to say the noise with which your noisy signal has a noise term, which I'm just going to say is normally distributed, not because the world is normally distributed, but because I'm trying to think of the simplest, dumbest model that I can. And it has some variance. So this then tells us the probability that someone thinks the Democrat will win is going to be a function of how close the election is and how noisy their signal is, right? And so this actually, as you can see, this actually defines, this simple model just defines a simple probit regression where when I run this probit regression, the coefficient on the vote share is going to be equal to the standard deviation of the noise of people's individual signals. And so when I run this probit regression, it tells me that sigma sub epsilon, my best estimate of that is 0.15. So that's an estimate of the noise with which each person sees the final outcome of the election. It's actually a very noisy estimate. And so then what I can do is that then tells me the expected vote share. So then I can say this was my, this was the equation I wrote down before, but now I have an estimate of sigma hat. So then this says the expected vote share given people's expectations is 50% plus cumulative inverse normal of the proportion who said Obama would win, scaled by how noisy their individual signals are. So the thing I want to emphasize here is I only need one term in order to be, I only need to estimate one term in order to be able to do this. That's why I say I'm tying one hand behind my back. The other thing is I estimate that one term, which is the noise with which people see what's happening, based on individual data, not based on the aggregate data. So I'm not estimating this term as a way of finding a line of best fit. I'm estimating it based on sort of a very simple structural model instead. So what does this actually look like? So here is how this equation works. So the horizontal axis now shows you the proportion of the population who say they expected the Democrat to win. The vertical axis shows you the actual Democratic vote share. And what that little equation gave me that I've now estimated is this dashed line. And you can see it's quite obvious from looking at this that this is not a line of best fit, right? And so it says, for instance, if 60% of people say they expect the Democrat to win, I read up to this dashed line and I read across and I say, I'm going to call that a forecast that Obama will win 55% of the votes. So now what I've done is I've taken my estimates, I've taken the polling data on the proportion of people who say they expect Obama to win, and I can use that dashed S-curve to invert that and figure out an implied estimate of Obama's two-party vote share, or the Democrats' two-party vote share. What does that look like? So now what I'm doing is on the horizontal axis, I'm taking the implied forecast from the expectations poll, and on the vertical axis, I'm showing you the actual outcome. Okay? So this implied forecast is just a simple manipulation of the proportion who say they expect Obama to win. The good news here is, again, you see a whole bunch of green dots that are pointing northeast. So we're not doing too badly here. So the question then, my research question, is basically a horse race. Which of these two graphs, the first graph, always I'm going to show you intentions-based forecasters in blue and expectations in green. They're both trying to predict the same thing, which is the actual Democratic vote share. Here, on the left, using the blue, is the voter intentions question, and on the right is the example using the expectations-based question. So the question is, which graph is prettier, the green graph or the blue graph? Right? And you can stare at that for a while, but of course that's not how we do econometrics. We actually measure things. So what I do is I take both of these and then run them through the standard forecast evaluation exercise stuff that we do. So when I used voter intentions, the root mean squared error in predicting any given election is 15.1 percentage points. When I use my voter expectations, I get that from 15.1 down to 8.9 percentage points. And that's obviously enormously statistically significant. So now this is, compared to the exercise before, what we're doing is a little bit harder. We're not just trying to predict who's going to win, we're trying to predict by how much. But the other thing it's doing now is it's using all the data. Because in the election, which both of these forecasts point in the same direction, we get to say, well, still who was closest. And so that gives us more statistical precision. The mean absolute error, if you're using voter intentions, is 11.5 percentage points. And if you're using the transformed version of voter expectations, if we're using my measure, you can halve that to 6.7 percentage points. If you want to figure out how often you'll be right, if you use my measure rather than the other measure, my measure is closer 65% of the time. My measure is correlated with the actual outcome at 0.76. Voter intentions are correlated with the eventual outcome at 0.57. We can run an encompassing regression, which is to say, the encompassing regression asks, if you're interested in predicting the outcome, should you put any weight at all on voter intentions, given what we now know about voter expectations? So you run a regression of the actual election outcome on both of these forecasts. When you run that regression, my measure comes in clearly statistically significantly. The other measure comes in statistically insignificant. So what that says is I cannot reject the null that once you know about voter expectations, there's no point even looking at voter intentions. A different exercise is to say, given that I have these two measures, what are the optimal weights that I should put on them? And so this is, you run the same regression, but you turn the constant off and you force the coefficients to add up to 1. When you run this regression, it says you want to put 91.5% weight on the measure of voter expectations and 8.5% of the weight on voters' intentions. So that 8.5% is in fact statistically significant at 10%. But in terms of economic significance, it's saying you want to put 90-10 weights. Roughly speaking, you really want to know about voter expectations and you don't really care very much, if at all, about voter intentions. And we can do a little bit of robustness checking on this. We could say, is this different in elections that the Democrats are expected to win or Republicans are expected to win? Or we could say, is it different in close elections versus distant elections? Because we care a lot about close elections. We don't care so much about landslides. And so what I've done is I've taken each election and then I've broken them up according to, I wanted to break them up based on some ex-ante measure. So it was like, how close was this election in the previous cycle? Right? So for Michigan, I'd be saying, how close was this 4 years ago? And so we see these are the states where the Democrats always win. So this is like California. And the mean absolute error, so you want to have a small bar here, is larger for the voter intentions forecast than it is for the voter expectations forecast. The difference between them I'm showing is the purple bar, and that has a confidence interval around it. And so this shows you the difference here is statistically significant, even when I'm looking at just a quarter of my observations. These are the extremely strong Republican states. So this would be like Texas, which Democrats never win. And you can see here that the intentions-based forecast is often wrong by a lot. The expectations forecast is wrong by less. The difference between them is not only large, it's also statistically significant. More importantly, we care a lot about close elections. And in close Democratic states or close Republican states, again, we see a dramatic improvement in our ability to forecast. And that improvement is, again, statistically significant. Remember, one of the funny things about my data is these are not independent samples of 1,000 people. Remember, some of the states are as small as one observation and maybe some are as large as like 250. So these are not large survey samples. So what I then did is I broke up the result according to whether I'm looking at small or large sample sizes. These are quartiles. And you see that the difference between the blue and the green bars is statistically significant, even in the large samples. It is also statistically significant in the small samples. The difference looks to be a little bit smaller once you get to larger samples. And I'm going to say more about that later on. I think that actually makes sense. But the difference is there and is represented at each and every sample size that I have in these data. Okay. So where are we? I've made two claims so far. The first is, if you want to predict who will win, then you do a better job by focusing on voter expectations. The second claim is, if you want to figure out by how much, you do a better job by focusing on voter expectations. I've committed one big statistical sin so far, which is I've been treating the results of public opinion polls as if they're forecasts. But the result of a public opinion poll is a sample moment, not a population moment. And I don't know how much this is happening in Spain right now, but there's a big movement in the US. If you've ever heard of Nate Silver and 538, there's a big movement among the US of doing a better job with polling, sort of treating these data in a statistically sophisticated way, the way that you and I would, rather than the way that pollsters would. And so what I want to show you next is if we treated these data in a statistically sophisticated way, that we still get a similar result. Let me try and do this. I'm going to do it a little bit quickly. I'm going to throw some Greek letters up and not spend a lot of time talking about them so that we can get to the more interesting parts. So far what I've done is I've shown you that simple forecasts, these, if you say 54% of people intend to vote for Obama, I've treated that as a forecast Obama would win 54% of the votes. But that's a sample moment, not a population moment. And it is a sin to treat sample moments as population moments. I know this because we always put hats on top of sample moments, so therefore they must be different. So I'm going to take those hats seriously now. So in order to do that, we're going to think about a poll result as being a sample moment, as being a noisy indicator of truth. So the poll result equals truth plus bias plus an error term. And if what I want to do is take a poll result and I want to think about what is the statistically efficient forecast from that poll result, it turns out the answer is fairly simple, which is if you want to minimize the mean squared error, the best forecast is the typical outcome for an election. And then what you want to do is scale by the signal to noise ratio how atypical this poll is. Okay? So this is just what's called a shrinkage estimator. So if you're from that world, it should be quite familiar. If you're not, if you're from OLS land, this should also be quite familiar to you, which is if you run a regression of something true on something with measurement error, then you get an attenuation bias, right? That attenuation bias when you're forecasting is a good thing because it helps you minimize the mean squared error. And so this is just saying when you take account of the fact that samples have measurement error, then what you want to do is you want to scale by the signal to noise ratio. So this should be pretty easy, but what I'm going to need to do is I'm going to need estimates of each of these moments, of each of these coefficients, in order to transform my polling result into an optimal forecast. How am I going to do that? So you can see here, so I need to know what the average Democratic vote share is in a typical election. That's easy, I can measure that. I'm going to need to measure the variance in election outcomes across elections. That's easy, I can measure that. I'm also going to need to measure the average bias in public opinion polls. That's easy, I can measure that. The one thing I'm going to need to do is measure the variance of polling errors. That's going to require a little bit more work. There are two reasons why polls have errors. One is sampling error. So I know a lot about sampling error because it's a binomial thing, right? It's a binomial. I'm asking you going to vote for the Democrat or not. So therefore we know what the variance of that is. The variance of a binomial is P, 1 minus P on N. In my case, that's going to be equal to the vote share times 1 minus the vote share divided by n, where n, it says nf here because I'm talking about the effective sample size. We're going to put that aside for now. Because v1 minus v, the vote share times 1 minus the vote share in elections is always close to 0.25, right? Even if the election is 60-40, 0.6 times 0.4 because 0.24, that's close enough to 0.25 that this just simplifies to 1 on 4 times the sample size. So I know what the sampling variance is. The other reason that polls make mistakes is, remember, we take the survey a month before the election. And so even if you sampled public opinion perfectly, public opinion might change over the ensuing month. And so then you need to take account of how much public opinion tends to change over the ensuing month. Actually, that's quite easy for me to measure because, remember, in my data, I see how people say they expect to vote a month before the election, and I see how they report having voted a week later. So I can use that in order to measure how much general public opinion tends to vary between before the election and election day. So now I can measure the variance of polling errors. So what that means is this was the expression we started with before, and each of those Greek letters now I've measured, and I end up with this. So this is the weird magical formula. I didn't think it would look like this, but it does. If you want to convert a poll into a statistically efficient forecast, it's going to be a function. It's going to have all these weird numbers running around. We want to account for the bias. We want to scale it. We want to take the poll more seriously the larger is the sample size, which I guess is kind of obvious, right? So when I put my polling numbers, who do you intend to vote for, and I put them through this apparatus, then I get now a statistically efficient forecast of the Democratic vote share versus the actual Democratic vote share. And you now see this does a pretty good job, right? So that's for who do you expect to vote, who do you intend to vote for. Now what I need to do is do the same thing for who do you expect will win. So I basically do the same exercise again, thinking about when 65.7% told me they expect Obama to win, that's not a population moment, that's a sample moment. And I need to think about what is the actual proportion of the population who thinks Obama will win, and then what are the implications of that for Obama's likely vote share. So I do a very similar exercise there, and I get this magical formula. And this magical formula is very similar to what I was doing before. It's still an inverse normal, and it's still scaled by the noise of people's signals. But then you want to take these expectation surveys more seriously when they're based on a larger N. And then the rest is just taking account of the bias as well. And so now I have a statistically efficient expectations-based measure. That's what I'm showing on the horizontal axis. And on the vertical axis, I'm showing the actual Democratic vote share. Let me put all this together. What I was showing you 10 minutes ago was if 56% of people say they intend to vote for Obama, let's call that a forecast that 56% will vote for Obama. That was the simple versions up here, and we ran a horse race between this top chart and this top chart. Now what I'm doing is I'm saying, yes, but let's think about this like statisticians who want to use these polling data in a statistically efficient way. And this, it requires a little bit of work, but this is what it looks like if you're using the expectations, and this is what it looks like if you're using the intentions. And so now my research question is, which chart looks prettier, the bottom green one or the bottom blue one? Okay? You could stare at them, or you could look at the numbers. And so here we see that the statistically efficient voter intention survey has a mean absolute error of 5.6 percentage points. So that's actually fallen a lot. When you do all this work we were just doing, you can do a lot better job in forecasting elections. You shouldn't take sample data seriously as forecasts. You should think about the fact that they're noisy estimates. So the mean absolute error is 5.6 percentage points, but the voter expectations measure, the equivalent voter expectations measure, the mean absolute error is 4.2 percentage points. So it's still a large improvement in forecasting ability. It's still statistically significant, and it still comes for free, right? And you get the same sort of picture when you're using all these alternative measures of which one is doing better. And so if you ask what are the optimal weights that you should put on each, you should still put about 90% of your weight on the expectations-based measure and only about 10% of your weight on the standard poll. And let me underscore again, if you read standard media accounts or if you listen to political advisors, the weights that they put on this is instead they put 100% weight right here and 0% weight right there. So relative to standard practice, this is a surprising result. Okay. let me skip the archival data so we can get to the stuff about why, but so far all of this has been based on the National Election Studies data set. The next thing we did is I had my graduate students spend a year in the library looking for every poll ever taken anywhere in which they ask both the voter expectations question and the voter intentions question. Actually, let me show you this. The reason that this is a useful test is now we're talking about real-world polls that have sample sizes of 1,000, 2,000, 5,000, sometimes 500, right? But these data are a mess because we're taking every single poll where they've ever asked both of these questions. And sometimes they ask a lot, sometimes they don't ask very much. It's weird. So I've divided the data according to, is this 3 months before the election, 3 to 6 months, or more than 6 months before the election? I have a bunch of presidential data. I have data on every state for 1936, because they liked this question back in 1936. I have it for a bunch of gubernatorial elections, some senatorial elections, some mayoral elections, and some referenda. And then we found some from Australia, some from Britain, some from France, and some from other countries. Each of these cells is very small, so none of them should be taken seriously. Even say we have a lot of American elections, but realize we have 161 observations, but only over 19 elections, so they're not independent observations either. So I wouldn't focus much on any individual number. What I would do is come to the bottom and I'd say, on average, for polls taken in the 3 months leading up to election day, voter expectations gets it right 83% of the time, voter intentions gets it right 76% of the time. So that's roughly similar to what I was showing you before, right? 3 to 6 months before an election, I think here I got lucky, because voter expectations got it right 74% of the time, voter intentions only 56% of the time. That gap looks to be awfully large. So maybe I got a little lucky. But don't worry, we're thinking about elections taken, polls taken 6 months or more before. Voter expectations only gets it right 48% of the time, voter intentions gets it right 63% of the time. Let me give this final one some context. It turns out that if you just said, whichever party's currently in power will get re-elected, you would have done better than either of these polls. Basically, public opinion more than 6 months before an election is pointless. It has no predictive power above an incumbency effect. So I think the real lesson here is not that one is better than the other, it's that both are terrible. And there's not much information in public opinion. So that's sort of the real-world test. This is real polls that real pollsters are taking. Okay. So the question is why, and I've already given you a hint of what it is that I'm thinking about, which is I think what's going on is each of us knows how a bunch of our friends are going to vote. And so each of us, it's like treating each polling respondent as if they themselves are a pollster, right? Like each of them's a mini anthropologist. So what I'm going to do is I'm going to write down the simplest possible structural model to try and make sense of this. Let me warn you, I'm going to write down a version that's too simple and mostly wrong. And then what I'm going to do is I'm going to enrich it on the next slide and then enrich it on the next slide and so on like that. Okay. So my model is simply that each of us runs a private poll of m-1 of our friends and family. And it's m-1 because I'm also in my poll. So therefore I have m people in my poll. Okay. So what is the proportion of my social network who intends to vote Democratic? Well, let's say that my social network is representative of the entire electorate. Again, that's a problematic assumption. I'll come back to it. Okay? But if that's the case, then my private poll is going to be unbiased, and it's also going to have a variance equal to 1 on 4m. So therefore, the probability that I expect a Democrat to win is going to be the cumulative normal. This sort of surprised me when I first thought about it. It's going to be this function, the cumulative normal of 2 times the square root of the number of friends I have multiplied by how close the election actually is. So what this says is if I run a regression, a probit regression on does this respondent expect the Democrat to win versus how much the Democrats won by, the coefficient is going to be 2 times the square root of the number of friends they have. So it has a direct structural interpretation. That surprised me at first. Why would it be 2 times the square root of the number of friends I have? Well, one answer is in econometrics, everything's the square root of n. And the other is remember the variance of a binomial, p1 minus p on n, is 1 on 4 times 1 on n. And so the 2 here is coming out as being the square root of the 1 on 4. So I can run this regression, and I can figure out how many friends people have, right? And I run this, and I get a coefficient of 11.1. So that says each of us, let me be precise about this, each of us has an expectation about who's going to win the election that is as precise as if each of us had run a poll of ourselves plus a representative cross-section of 10 other people who could potentially vote. Okay. So the first problem, though, is that our social circles are not, in fact, representative of the entire electorate. I live in Ann Arbor, Michigan, and it turns out like everyone there is a Democrat, right? So that's not actually a problem if people understand that, right? If I were in Ann Arbor and I went to the faculty lunchroom and 3 out of 10 people said they were going to vote Republican, understanding where I am, I would then predict a landslide for the Republicans, right? So what I would do is I would de-bias. So if I understand that there's this bias, then what I'm going to do is I'm just going to take the results of my private poll and I'm going to subtract off the bias term for how biased my social network is. And then everything still goes through and actually nothing changes. So if people are responding this way, my model still works. And it's still as if you have 10 friends. So there's another thing, though, which is there are correlated shocks within social circles. So it's not just that everyone the people in my department are more likely to be Democratic. It's that we're more likely to move left or right together. There may be some particular issue if someone proposes pay cuts for economists. You would see everyone start to move in the opposite direction. So now this adds a form of correlated noise. And so now the result's actually still going to be similar, which is the result of your private poll is still going to be unbiased, but now the variance is going to be larger. And it's going to be larger because you're no longer taking a poll of a representative cross-section. You're taking a poll of a whole bunch of people who have correlated views. And so the difference there, of course, is basically the standard Moulton correction, right? You basically have a clustered sample. And so then the question is, if what I want to... So another way of saying this is people's signals are as precise as if each of us had run a poll of ourselves and a representative cross-section of 10 people. But if we have correlated shocks, say with half the variance being common, then that's equivalent to running a survey of 20 friends who have correlated beliefs, right? I don't actually know what this lambda term is. I don't know how correlated beliefs are within social circles. But I can estimate it. Because in 2000, National Election Studies asked people, don't just tell me who you voted for, tell me who your friends and family voted for. And so from that, I can actually see how correlated voting is within social networks. So what I can do is I can estimate a model of, did I vote Democratic on what actually happened, plus allow for a random effect for your social circle and an idiosyncratic effect, right? And so when I estimate that random effects model, I get an estimate of that 45% of the variance is correlated within social circles. So this now allows for reinterpretation. Instead of saying each person has a signal that is as precise as if they had surveyed 10 independent people, each person now has run a survey as if they've run each person's signal is as precise as if they'd run a survey of 20 people who have beliefs that are correlated at this level. Okay. The next thing I did, I was halfway successful in the next part of this research, which is one of the other things I do is I actually consult to Gallop. And so I went and I talked to Gallup's pollster and I said, look, this is great. You can do a much better job if you ask people who they think will win. And he said, well, can you do an even better job by doing something else? And I said, yeah, what I want you to do is ask people how many people they think will vote for each candidate, right? So they ran a little pilot survey for me, but it's really just a pilot. I got 81 people. And they did this before the New Hampshire, the Iowa, the Nevada, and the South Carolina primaries on the last election cycle. And they said, they'd call them and say, think about the Republican primary. How many of your friends are going to vote for, at the time it was Sarah Palin, John McCain, Mitt Romney? And then what I did, rather than reporting the answers, I just counted up how many friends they reported on, right? Remember, my model says they should be reporting as if they have 20 friends, and they know how 20 of their friends are going to vote. Here's a histogram of the total number of friends that people reported on. So there was one guy who thinks he has 150 friends, right? So Facebook friends don't count. But the rest of the distribution, actually, most people are reporting on sort of 10, 20, or 30 friends. They report as if they believe they know how 10, 20, or 30 other people are going to vote. The median of this distribution is 10, the mean is 21, right? My model says that number should have been 20. So that's a reasonable match, and it's a completely independent way of getting at this question. I'm going to skip this next bit and just go to the fun part. Okay, so why is it that political scientists have ignored this question for so long? And the reason is, it turns out that your answer to who do you think will win is highly correlated with who do you intend to vote for. And so the political scientists, there's actually two, and so this is an example, I'm showing you the correlation on average. And you see that among people who intend to vote for the Democrat, 69% of them expect the Democrat will win, and 31% expect the Republican to win. Among people who intend to vote for the Republican, 27% expect the Democrat to win, 73% expect the Republican to win. And so this looks like, people are just kidding. Like, it looks like this is irrational. So there are two interpretations of this. One is the psychologist's interpretation, which is this is just wishful thinking. That if you are going to vote for the Democrat, you wish the Democrat will win, so you say, I expect the Democrat will win. The political scientist's interpretation just reverses the causal error. They say, well, if you expect the Democrat to win, then everyone wants to vote for the winner, therefore you're going to go and vote for the Democrat. My story is actually this is rational. Remember, you're taking a survey of yourself plus 10 of your other friends. You already know how one of those 10 people are going to vote. And so the fact that you know that you're a Democrat makes it more likely that in the survey of you and your friends, that will turn out to be Democratic, right? And so it turns out you can actually take my model, take it seriously, calibrate it, and you can actually largely match, not entirely, you can match 2/3 of this correlation. So it may just be this correlation reflects people who are rationally reporting the results of their surveys, but they happen to be in their own surveys. Okay, let me now tell you the fun thing that we can do, having figured out the correlation between expectations and intentions. So the first thing this slide should do is convince you that I used to teach in a business school because it's got little men on it. But normally what we do is we try and find, standard polling practice is you try and find a representative cross-section of the United States or any electorate, and you ask people who they're going to vote for. What I've been doing is I've been taking the same representative cross-section and asking them who they expect will win. This is actually a deeply problematic technology. It is becoming increasingly difficult, nearly impossible to get representative cross-sections. People now are on cell phones, people don't answer the phone, rich people are almost impossible to get hold of, and so the idea that we get to have representative cross-sections is increasingly something that pollsters, they still lie about it, but pollsters really aren't going to be able to have representative cross-sections much in the future. So I'm going to do something really crazy. I'm going to throw away half my sample. And I'm going to focus only on the people who say that they intend to vote for a Democrat. Right? So I have now done something totally nuts. I've halved my sample, and I've taken the most biased sample you can imagine. I'm only going to survey Democrats, and I'm going to try and figure out who's going to win the election just by surveying Democrats. The thing I'm going to do, though, is remember my model reveals to me the correlation between people's intentions and their expectations. So what I'm going to do is I'm going to take the result of this survey, I'm going to feed it through my model, de-bias it using the results of that model, and then use that to forecast the outcome of the election. Right? Here's what happens. So now I'm forecasting the outcome. The intention survey, I'm still using the whole representative cross-section, so the sample's twice as large and actually representative. Expectations, now I'm using half the sample and a totally biased sample. And you can see that actually the mean absolute error is still lower when I'm using half the sample and the biased half and asking the right question. I don't have a ton of power here, but it still looks like I'm actually doing a better job. And by the way, this isn't just a statement that Democrats are smart. The other thing I can do is I can throw out all the Democrats and only focus on the people who say they intend to vote for the Republican. And when I do that, I still find slightly lower forecast errors doing this than using the entire representative cross-section and asking people who they intend to vote for. The reason I'm excited about this is the reason that pollsters are excited about this. You no longer need representative cross-sections if you want to do electoral forecasting. Failing to get a representative cross-section is deadly if you're focusing on voter intentions, right? If you only ask Democrats who they're going to vote for, you'll always forecast the Democrats going to win. But if you're asking them who they expect will win, then you can have very unrepresentative cross-sections and still do a reasonable job at forecasting. And that, I think, is very much the future of public opinion polling. Let me conclude just by giving you an out-of-sample story. The Republican primary in 2012 was a crazy, crazy roller coaster. At a certain point, Herman Cain, it was a roller coaster that makes public opinion polling, standard intention surveys look terrible. At a certain point, Herman Cain topped the polls. In fact, at a certain point, nearly everyone had a chance to top the polls, right? It turns out, though, if you looked at who people expected would win, at no point was Mitt Romney ever in doubt. And so the newspapers are writing these incredible narratives about how Romney's in trouble, but if you use this alternative forecast, he never was. There was another point where Rick Santorum was topping the polls. And let me tell you, you don't need to know a lot about American politics to know that Rick Santorum is never going to be president. But the polls said he was, or he was going to be the nominee. Instead, if you asked voter expectations, voters understood that this was just a flash in the pan. So it came the day before election 2012, and the New York Times called me and they said, who's going to win according to these expectations polls, Justin, and what do you think is going to happen? And at the time, most pollsters and most election experts like Nate Silver were saying Obama's going to win by 1 or 2 points. It'll be like 49-51. And I took the results of the survey, which 50% said Obama would win, 36% said Romney would win. And I put it through my formula, and it came out within a forecast that Obama would win 53% of the vote share. This was an incredibly embarrassing forecast. It was very unlikely Obama would do this well. But I thought, what should I do? I thought, I'm just going to report this honestly, and it's going to be embarrassing, and I'm going to look bad in 2012. Hopefully I'll look better again in the future. It turns out Obama won 53% of the votes in 2012. Now, that actually wasn't reported that way on election night, because on election night they hadn't yet counted New Jersey and California. So everyone the next day thought Nate Silver got the election right, but actually if you waited 2 weeks and waited till you counted all the votes, this number turned out to be bang on. So where does this leave us with American politics? If you thought 2012 was crazy, just wait till 2016. As you likely know, Donald Trump is on top of the polls. A standard view among American political scientists is that that is going to be a fleeting thing and he'll be gone any moment now. That's been something they've been saying for 4 months in a row. And he is still on top of the polls. I think that that's probably right. But still, the thing that's different about Trump compared to the previous elections is now he's not only topping voter intentions polls, he's also topping voter expectations polls. So this leads me to say, I don't necessarily think it's a sure thing that Trump will win, but the view that we can just ignore the possibility, I think, is no longer true. I think there actually is a very real chance he ends up as the Republican nominee. Let me stop there.
Fortunately, we are 1 year away from the election, right? So,
We are, yes.
and you said that it's too far. So.
Yes. Well, except for the Republican nomination is not. We're now 3 months away from that.
Oh, 3 months. Okay. So, Manuel.
Yeah.
Hi. So I think if you ask me who is going to win the election in Spain next week,
Yes.
probably I'm going to think about the 20 or 30 polls that have been publicized in the last weeks, and I might give you a guess based on that. But I'm sure this is not what you are trying to capture. So I was wondering if in your data, can you look at some polls where actually we know that the respondents, they did not have access to other polls when they reply to who they expect to win?
Yeah, it's a great question. So let me give the defensive answer first, which is if I want to be in the business, I think I've got 2 microphones on. So, is the other one off? Okay. If I want to be in the business of predicting election outcomes, I don't care why, right? I just do a better job by asking this question than that one, and I will be smarter than all the other pollsters out there. That's the defensive answer. Let me give the non-defensive answer. So the story I've been telling is that each of us is bringing in rich information from our social networks in our neighborhoods. And you're right, it could be that instead what we're doing is we're all watching CNN and we're reporting whatever happened on CNN. This is the part of the talk I skipped over. If that were true, then you and I should have incredibly correlated beliefs about who's going to win, right? Because we both watch CNN. And so it turns out what you can do is you can the extent to which people have different beliefs is a measure of how idiosyncratic their information sets are. And it turns out if you calibrate a model based on this, which is to say that the public opinion poll is like it's a random effect, and then each of us has an idiosyncratic effect, it turns out that like 80 or 90% of the variation is idiosyncratic. And so that's why it's true that the simple models I wrote down were false, but they're not very false. So the fact that, in 2008, only 65.7% of the population thought Obama would win, that's crazy. If you'd seen any public opinion polls, it was obvious that he would win. So that tells me there's something else going into people's expectations. I don't know exactly what it is, but it may well be sort of the idiosyncratic stuff I'm thinking about.
Yeah, other question up there.
So what about second-order beliefs, second-order expectations? So according to your model, if you bring not only your friends, but the friends of your friends, the forecast will be better. So does any poll include second-order beliefs, second-order expectations?
Right. Presumably it does, or it could. So, of course, we economists think that everyone is incredibly sophisticated, and occasionally I go out and talk to people, and it turns out maybe they're not. So that's one answer. Let me give a more precise answer. The results, the precise way of describing my results is each person, their expectations are as precise as if they had run a poll that had as much information as a representative cross-section of themselves and 10 friends. That doesn't mean that they're actually running a poll, right? So there are many sources of those beliefs. And so it may be that there are lots of things. It may be that they each have 3 friends, and they also know how each of their 3 friends are going to vote. So it could be the second order stuff. It could be that they don't know about what any of their friends are going to do, but they know how many yard signs they saw, how many stickers they saw. Or it could be they know how many phone calls they got from each of the various candidates. So whatever it is, I want to say it's idiosyncratic for the reasons I gave Manuel, but it's not necessarily that they're literally running a survey. Instead, what we're doing, the chief pollster at Gallop is actually really interesting to talk to, and the way he describes this is treating your respondents as mini anthropologists. The way I describe this is treating your respondents with respect, which is they have a bunch of information, let's extract it. And the commonality to your question and Manuel's is, I don't know what that extra information is, but what I do know is that it's informative. That's why we want to get hold of it, and we can get hold of it for free, so why not?
Yeah, I have a question here.
Thank you for the talk. So you said Facebook friends don't count, but maybe they do, no? So,
yes.
But I guess the interesting part there is that maybe it's noisier, no? The information you get is noisier. If you report a smaller set of friends, then you get a more accurate information, no?
Yes. So this was one of the reasons. Remember there was a chart where I showed you how well these have done in every election cycle? Because you could imagine as the media environment is changing and as the social environment is changing, then the size of each of our information sets is changing. And so the advantage of one poll over another depends, and it does depend, it depends on the social context, right? So the good news for forecasting elections is it appears to still do as well today as it did 50 years ago. The bad news for the broader project, remember I sort of said, I'm excited. For me, polling is just a laboratory. What I care about is this a better way of measuring public opinion for lots of other reasons, for market research, for macroeconomics and so on. One of the things you get out of the value of writing down the model is that it tells you it will vary with context. So there are some things we talk with our friends about a lot, and there are some things we don't talk to our friends about very much. There are some things where the information within a social circle is highly correlated, and there are some things where it's not. And so just because I do a better job at predicting US election outcomes doesn't mean that I would do a better job at predicting whether the Gap should make red jeans or blue jeans. So it's going to be context specific, but this is encouraging. So this is just, think of this as a proof of concept. And of course, as any part of the underlying structure changes, then how well it performs will change.
Okay. One last question.
Thank you for the talk. I was just thinking about the upcoming Spanish election again, and I literally have no idea who I'm going to vote for, but I think I have a reasonable idea of the fraction of votes the different parties are going to get. And I'm thinking that you're not capturing this effect because you're only counting people who give you an answer for who you're going to vote for and who you think is going to win. So I think there's even more information that you could extract if you actually took into account that a large fraction of people don't know who they're going to vote for. Is that the case?
That's correct. So in order to, for simplicity, what I wanted to make sure I was doing was asking the exact same people the 2 questions. And so what that meant was I'm throwing away all information from people who say they don't know who they're going to vote for, people who say they're going to vote for a third party, and this is the big one, people who aren't going to vote. They all have information. So if you're asking about voter intentions, you've got to throw all those guys out. When you're asking about expectations, you don't. And so in the paper, I'm not using that information, but those extra people are informative. And so if you were literally a pollster with a fixed budget, my approach means you can get extract something useful from everyone you call, and voter intentions requires that someone you're going to call is going to vote, they're going to vote formally, they know how they're going to vote, and they're going to vote for one of the major parties. And that actually knocks you down to about 60% in many countries. So again, it's cheaper this way.
Okay. Well, that was a fascinating talk. Thank you very much. And we need to stop here. Actually, I wanted to remind you that right away we're holding the General Assembly of the association, so you are all welcome to stay if you want. So join me with...